Alright, 2.3 Intro to Functions. I'm operating on low battery power because I'm using the backup iPad that wasn't charged. So we're going to go through all the examples first and then probably do practice off of the board up there for explanations later if we have time. For the first one is the vertical line test, and that's exactly what it says. You draw a vertical line over a graph to see if it touches in one spot or in two or more spots. If you can draw a vertical line and it touches in only one spot, the answer is yes, that thing is a function. If you draw a vertical line and it touches in two or more spots, the answer is no, it is not a function. So in this graph, I'm drawing a vertical line here, 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 and here. Wherever I draw a vertical line, how many places is it going to cross? Just one, so the answer is yes. Crosses in one spot, no matter where you draw a vertical line, the answer is yes. That does represent a function. Here's a vertical line. Is this a function? No, it crosses in two spots. Is this a function? Yes. Is this a function? Yes. Adkins M, is that a function? No, that's right. Akers is not here. Bayes, is this a function? No, that's right. Next one is Daniels, is that a function? Yes. Davis, is that a function? Yes. Gilkey's not here. Hellier, is this a function? No, it is not. State whether each relation represents a function. The way you do this is by looking at the first item in each ordered pair. That is the x value. Do I have x values that are the same in this set of ordered pairs? No. So in that case you could say yes, this could be a function. For this one, do I have two x values that are the same? Yes, I have -1 and -1. Are these two x values associated with different y values? Yes, so the answer is no, that is not a function. You cannot put a -1 into a function and get a 2 and then put that same -1 in and come out with a 3. That is not a function. This one goes to Johnson. Yes or no?
Yes.
That is a yes. That's right. Next one. This goes to Jones. Yes. Lewis.
Yes.
Yes. Mollett. Answer is no on this one. We have 1 and 1, but they point to -9 and -8. Otworth. We have a -2, -2, but they're pointing to different values, so that is a no. Salyers M.
Yes.
Yes. Sanders.
Yes.
Yes. This one goes to Adkins M.
No.
That one is a no. We have a 5 and a 5 pointing to different values. Alright, here are some examples. Evaluate the function for the given values of x. F of x equals 3/4 x minus 2. For x equals 12, 16, and 20, what this means is you put 12, 16, and 20 in individually, one at a time, in for x. So f of 12 goes in first, so 3/4 times 12 minus 2. 12 times 3 is 36, divided by 4 is 9, minus 2 is 7. For f of 16, we're going to go 3/4 times 16 and then minus 2. 16 times 3 is 48, divided by 4 is 12, minus 2 would be 10. And for f of 20, 3/4 times 20 minus 2. 3 times 20 is 60, divided by 4 is 15, minus 2 is 13. You get back 7, 10, and 13 for putting in these numbers. Whenever you put in a 12 and come back with a 7, you get 12, 7 for an ordered pair. It generates ordered pairs. So you can express it as this, or you can express them in order 7, 10, and 13. This is the exact same type of problem as what we just did in the previous example. If the domain of f of x equals 3x minus 2 is integer value such that x is between -2 and 1, find the range. The values that you plug in to the function are called the domain. What you get out of the function is the range. Domain x, range y. So it's simply a different wording. In this problem, it's asking you to plug in the domain of x between -2 and 1 such that they are integers. So in other words, you're plugging in -2, -1, 0, and 1. So 4 different problems to work out to get the range. The range is the y. So the y would equal whatever the results are from plugging in these 4 numbers. Use a graphing calculator to graph the function and state the domain and range. Put that into your y1. All you need to do is enter in -4x. Should look like this. Enter in -4x. If you have any of these plots highlighted, then you did not turn them off. This is the graph of y equals -4x. Your job right now is to figure out the domain and the range. The domain will be the x values. Here is the x-axis, left to right. Are there any restrictions on this x-axis? Is there anything that x cannot be equal to in this function, y equals -4x? Can I plug in a -10 and find a point on that line that matches up with -10? Can I put in a +5 like over here and draw a line down? Will it intersect that line at some point? If I did 3, -3, it'll intersect that line. Yes or no? Does this line go on forever? Yes, it does. So all real numbers will work for the domain. Any restrictions on the y? Are there any y values that are not included in this? Can I go on forever on the y-axis and then go left or right and still intersect this graph, no matter where it's at? So that would be all real numbers. Your next one, you should delete the -4x from y1 and put in 3x squared. When you put in 3x, it should look like this. And we need the domain and the range for this. The domain are the x values. Can I put in any x value? Can I go over here and go up, and at some point will I run into that graph? Is this graph spreading out to the right? Does it go on forever? So it'll never stop spreading out to the right. So at some point I will hit it if I go from here. What about here? Does it spread out to the left? Yep. So the domain will be all real numbers. What about the y value? on the y-axis, are there any limits on this? Any area where it does not go with the y? Where does it not go? It doesn't go into the negatives. Where does it go and stop and then go back up? 0. So that means your range would have to be such that y is greater than or equal to 0. It could not be in the negative territory.